we will be discussing question number 17 from Chemistry Gate Exam 2021. The characters of E, C2, sigma V and sigma V dash, symmetry operations in this order for valid irreducible representations of the C2V point group is or are. Four options are given. Option A 1 1 1 1, option B minus 1 1 1 minus 1, option C 1 minus 1 1 minus 1, option D 1 minus 1 minus 1 minus 1. So the terms E, C2, sigma V and sigma V dash given in this problem indicates the symmetry operations possible for this molecule. E is the identity, C2 is the axis of symmetry, sigma V and sigma V dash symmetry planes. Let's see how to solve this problem. First thing we need to know before solving this problem will be great orthogonality theorem. The main postulates of this theorem are: first one, number of irreducible representations or IRs in a group equal to number of classes in the group. So if we are considering this C2V point group which is given in the question, the character table will be like this. It has four symmetry elements: E, C2, sigma V and sigma V dash. So these are the four columns of this character table, and these columns will represent number of classes in the group. So number of classes will be 4, and the postulate is number of classes equal to number of irreducible representations. Since we have 4 symmetry elements, we have 4 columns, and these columns represents number of classes, and number of irreducible representations will be equal to number of classes in the group. Hence we have IR1, IR2, IR3, IR4. Always number of columns and number of rows will be equal in a character table. So that will be the first postulate. Let's see the second one, which states that sum of squares of the characters of the identity operations in the irreducible representations equal to order of the group n. Let's say the identity operation E has the characters K1, K2, K3 and K4. So according to the postulate, K1 square plus K2 square plus K3 square plus K4 square equal to n, which is order of the group, and we have to find out value of n. We know that E is the identity operation which will be a part of all the molecules, and this operations will make the molecule unchanged, and hence all the characters will be equal to 1. So K1 will be equal to 1, K2 will again be 1, K3 will be again 1, similarly K4 also equal to 1. So character for identity operation will be 1. This cannot be negative because the symmetry of the molecule will remain unchanged. So we have the answer for n, that is equal to 1 square plus 1 square plus 1 square plus 1 square, that is equal to 4. So in this case the order will be equal to 4. Let's move on to the third postulate, which states that the sum of squares of characters of all the irreducible representations or IRs will be equal to the order of the group, that is n. So previously we state that characters of identity operations the sum of squares of those characters will be equal to order of the group. And third postulate says that sum of squares of characters of all the irreducible representation will be equal to the same answer, that is 4, as per the previous slide. So here, let's say we are considering the IR1, it will be like 1 square plus L1 square plus M1 square plus N1 square will be equal to order of the group, that is 4. Assuming condition L1 equal to M1 equal to N1. So it will be like 1 square plus 1 square plus 1 square plus 1 square, that is equal to 4. These values can be negative also. Still we will get a value of 4. So this is like a hypothetical condition where all the values are becoming 1, where the symmetry of the molecule is not getting changed. That is also a possible irreducible representation, because if the symmetry of the element is not changing even after the operations, these characters will be 1. So that is the third postulate. Coming to the fourth one, which states that all the irreducible representations are orthogonal to each other. So here we can say that IR1 will be orthogonal to IR2, which means the product of these two characters plus product of these two characters plus product of these two characters plus product of these two characters will be equal to 0, which means 1 into 1 plus 1 into L2 plus 1 into M2 plus 1 into N2 will be equal to 0. Not only with IR1 and IR2, similarly IR1 will be orthogonal to IR3. IR1 will be orthogonal to IR4. IR2 will be orthogonal to IR3. IR2 will be orthogonal to IR4. And IR3 will be orthogonal to IR4. So that is the postulate. All the irreducible representations are orthogonal to each other. So keeping all these things in mind, let's solve the problem. So according to the question, 4 symmetry elements are given as E, C2, sigma V and sigma V dash, and C2V is the point group, and 4 options are given like this. So let's substitute these values in the character table and see how it looks. Since we have 4 symmetry elements or 4 columns in this character table, we will be having 4 irreducible representations, and after putting the values given in this options, we are getting a character table like this. And let's see which set of irreducible representations are correct. If we are seeing the characters for the identity element, we have a -1 here in this IR2. We already stated that for any molecule, the identity operation will not affect the symmetry of the molecule. It will remain unchanged. So a negative value cannot be possible. So which means this IR2 cannot be a possible irreducible representation. And if we are seeing IR1 where all the values are 1, all the characters are 1 here, and this was a possible irreducible representation as we were discussing in the previous slide, where E, C2, sigma V and sigma V dash, none of these operations are affecting the symmetry of the molecule. The symmetry is unchanged after this operations. So that is possible. So the first option where all the values are 1 could be a possible irreducible representations, but B cannot be a possible answer. And with respect to A, we can check whether C and D are correct or not, based on the orthogonality theorem, which states that each irreducible representation will be orthogonal to each other. So let's solve this. First we'll see IR1 and IR3. So according to which 1 into 1 plus 1 into minus 1 plus 1 into 1 plus 1 into minus 1, that is equal to 1 plus minus 1 plus 1 minus 1, that is equal to 0. So this is correct, which means IR3 is also correct. So option C can be the right answer. And coming to the fourth one, IR1 and IR4, 1 multiplied by 1 plus 1 multiplied by minus 1 plus 1 multiplied by minus 1 plus 1 multiplied by minus 1, that is equal to 1 minus 1 minus 1 minus 1, that is minus 2 and not equal to 0. Hence this is not possible here. Hence the fourth option, option D, cannot be a possible irreducible representation in this case. So only A and C are satisfying the conditions. So the answer for question number 17 will be option A and option C. For more details, you can go back to NPTEL reference, lecture 10-11, Chemical Applications of Symmetry and Group Theory by Professor Manavendra Chandra from Department of Chemistry, IIT Kanpur. The YouTube links for the same are also given here. Thank you.